Welcome everyone. My name is Luca Lombardo. I'm a PhD student at Politecnico di Torino, and my presentation will focus with a distributed and collaborative measurement system, and we will give an overview about these systems. We start with the measurement system, just a brief overview. Then we go in more details on wireless sensor networks, and we will give some constraints for design and also some advanced techniques for developing this wireless sensor network. And finally, we will give a case study. Originally, concentrated measurement system was conceived to perform measurement just in one point, but new development of communication system and also of new low-power electronic devices has permitted to develop a distributed measurement system and also to give a sort of intelligence and develop collaborative measurement systems. Concentrated measurement systems can be defined as one or more instruments that are placed in a given place and perform a given task. They suffer of some drawbacks. In particular, they are not able to give any information on the phenomena in sense of spatial information, and they lack of flexibility, and also in case of failure of one of these systems, all the system stop to work. So has been developed a distributed measurement system where more than one instrument are spread over a given territory and are able to perform the measurement in several points. So this type of systems are able to give spatial information of the phenomena and also are tolerant to the fault of some nodes. But still, this type of sensor lack of flexibility because it is often required the manual intervention of technical staff. So we arrive at the collaborative measurement system that are distributed measurement system but have the ability to cooperate together and perform the task. So to improve efficiency and try to sharing in the best way as possible the resource available to the network. Nowadays, the most typical implementation of a collaborative measurement system is wireless sensor network, and we will give some details on this. Wireless sensor network is just a group of sensing nodes spread on the territory and connected together using a wireless link. Async node can be also present, and it has the task to collect the data from all sensing nodes and eventually put them on, for example, the internet. There are basically three topologies of wireless sensor network: star topology, mesh topology, and tree topology. They differ for their implementation and also for their features. So according to the specific application, one can be preferred over the others. How nodes can be connected together? We have just here a few examples of wireless protocols: the Bluetooth, the ANT, the ZigBee, the Z-Wave, the LoRa, and the Sigfox, but many other are available. Typically, we put attention to the type of network that they can implement, for example, star, mesh, or tree, and also to the bit rate or the connection range. For example, LoRa and Sigfox are specifically developed for long-range transmission. Instead, Bluetooth and ANT or ZigBee are more suitable for short-range connections. Typically, this type of wireless link are works on the industrial medical bands, and the frequency go from hundreds of megahertz to some gigahertz. Wireless sensor networks find application in a lot of fields. They go from scientific research to industrial application, military application, but also, for example, cultural heritage, agriculture, and the surveillance for several types of events, public security, home automation. So they are almost used everywhere. But according to the specific application, we have several constraints that have to be taken into account. And here we have just a few of these. They are connected to the limited resource that sensing node have, so limited battery capacity, computing capacity, but also the sensing performance of the physical sensor, so for example sensibility, or noise interference present in the medium, in the radio channel. All of these constraints are connected one to the other, so optimize a wireless sensor network means to find a trade-off between all of them. One of very important optimization that can be performed is the maximize lifetime. Lifetime is the time that the network is operative, and we have highlighted the most important characteristics that are involved in lifetime maximization, in particular battery capacity, computing capacity, and also lifetime of course, latency, data throughput, and cost, of course, of the sensing nodes. Several techniques have been developed to try to optimize lifetime. We have just some of them, and we will focus on, in particular, on clustered networks, beamforming networks, mobile sync nodes, and collaborative users. All of these techniques are possible because of an improvement of electronic devices and the introduction of innovative sensors, and are focused on reducing power consumption, for example with energy harvesting, or implementing new efficient and powerful protocols. Clustered networks want to concentrate resource on a small amount of nodes, in this case sync nodes, and reduce the cost of the sensing nodes. So if there is a generic standard mesh network, this can be clustered, for example in 4 clusters, and the benefit is a reduction of the number of hops and a reduction of the data traffic in the nodes close to the sink. This improve both lifetime, of course, because power consumption of the network is reduced, but also reduce, for example, latency, traffic congestions, and give a better distribution of the resource over the network. Another interesting techniques is the beamforming, where the sensor network is considered like a faceted antenna array. In this case, all the sensors are connected and synchronized together, and they transmit cooperating together in order to generate a very high power but very directive beam. The benefit of these techniques is the increasing of the wireless range that can be also tens of times greater of normal networks, but require very expensive electronics for synchronization and also complex software. Another possibility is mobile sync nodes. In this case, the sync nodes are not stopped in a position, but can move, and moving they are able to connect to the sensing nodes. This way the distance between sensing nodes and sync nodes are reduced, and so power transmission can be reduced. This way lifetime increase, but increase also latency for data, because there are some nodes that have to wait to be near the sensing node to be able to transmit. Sensing nodes of this kind can be, for example, drone, robots, or also public vehicles for transport, and so on. In this framework, we can also think about, for example, collaborative users in a museum. It can be installed an app on the visitors' smartphones, and this app automatically connects to the sensor in the environment using Bluetooth, and from one side gives useful information to the visitors, for example, audio guide or text guide, and in background it collects data from the sensor and transmits them using the Wi-Fi on a cloud infrastructure. This way it is possible to implement collaborative networks at practically no cost. We at the Politecnico of Torino have developed such a kind of network that is especially suitable for indoor and outdoor applications. The network is organized with small sensing nodes and a dedicated receiver, use the Bluetooth low energy, and so is compatible with the most of smartphones, and have a very long lifetime. The sensing buttons have a dimension of 36 millimeters for 16 millimeters, have an onboard memory, and also a battery under the circuit. Are very compact and can work unattended for about 3 years. So it is a very long operative life. The architecture is very flexible, can work both in online or offline scenarios, and have a dedicated cloud. Data latency is about 5 seconds. The dedicated receiver are implemented using a PC on single board, in this case Raspberry Pi 0. This is quite powerful and have both Bluetooth and Wi-Fi connectivity. Here we can see how the network can be arranged. We have 3 different layers. The back-end layers, where the sensor, the physical sensor, are placed in the monitored site. A bridge layer, where there are utilities for transferring data from the sensing nodes to the final users, that is the front-end layer, using the internet and the cloud infrastructure. This can work both online and offline, according to the presence of an internet connection or a power supply. How the users can access data? Data are available using the cloud remotely. We have basically 3 different possibilities. An app on the smartphone, where all data are available. This is realized using the mPanel architecture. Then we can arrange a website that can be accessed using generic browser, or a dedicated downloader software that can also process data for specific applications. Here we have an example of use of this network. We have placed 6 sensors in the basement of Cairo Museum in Egypt, and we have recorded data for almost 1 year. Data quality is quite good, and is clearly visible the season from the start to the end of the recording. What is the work? We are trying to add to this sensing network a LoRa connectivity. LoRa connectivity that is a long-range transmission protocol will be able to give to our networks a long-range control possibility. So the idea is we use original Bluetooth node and add the LoRa module. We can see that the dimensions are quite equal. And in this way, our network will have Bluetooth for short range transmission and LoRa for long range transmission. So this will improve significantly the flexibility of a network. So, to conclude, a distributed measurement system are very advantageous in respect to standard system, because can provide spatial information over phenomena, have improved the reliability and flexibility, and have a high scalability. Usually, a distributed measurement system and collaborative measurement system are implemented using wireless sensor networks. But we have seen now these networks required a very accurate design in order to find a good trade-off between all the constraints and the limitation of these systems. And this design involves a multidisciplinary approach that goes from sensing development, software development, but also the improvement of electronic devices. So, thank you everyone for the attention. Here we have further suggested ratings and also my email if someone wants to contact me for more information. Thank you.